So, we're going to talk about my personal view into the future of authentication and authorization here. Although, because we don't have enough time, we'll only focus on authentication. You have to pay extra to get the authorization later. So let's see what authentication is. We've seen many of these examples today, but basically authentication requires a login page. So this is what we saw earlier by Cognito. It asks for an email and a password, or a username maybe, or a phone or something else. But we're going to be talking about the password field today. And this is because it has several problems. The first of all is difficult to remember passwords. So you need to have them be very long and complicated. It's not really easy to remember them, and they also leak. Like websites get hacked, databases have unauthenticated access or something, and the password can be retrieved by anyone and then reused in other places. And this means you need to use different passwords, which makes it even more difficult to remember them. And they can also be phished, like someone can trick you into giving them your password, or as it used to be by design many years ago. And using passwords properly is very difficult, even for security professionals. So normal people don't stand a chance, basically. And it's very easy to get something wrong and then have problems through that. The solution to that are password managers, where you can store all your passwords and have them autocomplete everything and do everything for you. They store everything and you don't have to remember things. The problem with that is that there are too many password managers. So if you don't know about technology, you have to go and pick a password manager. And how do you pick one? Like, do you trust what your favorite influencer is promoting this week? Do you have some other criteria to do this? Because some password managers can be bad, and other password managers have such a terrible user experience that basically renders them completely unusable. And of course, there are other password managers where you need like a Kubernetes experience to set up and maintain securely. It's very difficult to find the few good password managers that exist out there. So, oh, I see some emojis. I don't know, do you see them too in my screen? Not sure what's happening. Anyways, moving on. Passwords, basically, password managers, they solve the problem. It's no longer difficult to remember passwords. They store them on your disk or in a cloud or something. So this problem is solved, but your passwords can still leak. The password manager cannot do anything to prevent a website from getting hacked and your password stolen. However, you can use a different password for every website, so it's not really that bad. And it also does, most managers do something to prevent phishing attacks. For example, they will not autocomplete your password if it's saved, if you try to do that in a different website than the one you saved it from. But still, you can manually override it, or you can have some way of this password be sent to someone else. And because there are so many, you have to sync your passwords across all of your devices and operating systems. They still have problems. So they're not easy for the everyday user to use. And these are passwords, though. They're no longer enough, unfortunately. They are that bad that we also need even more passwords on top of that. We need two-factor authentication, and security experts typically ask you to set it up. They say it's a very good thing, and it is. It's great. It can help prevent a lot of those attacks. But now you need a phone number nearby where you can receive an SMS message, or you need to have an application that will generate a 6-digit code. There are still problems. And all these problems are because of passwords. They create all those problems for us, so the natural solution to that is to get rid of them, and this is called passwordless. The problem is that this is what our login page looks like now. We remove the password field. What do we do now? Do we just allow users to just set up an email and log into the site? This is not really viable. So we have to do something for that. And while doing so, we have to keep in mind all the problems that passwords have. So we need to find a way to address all those problems, or at least do better than passwords if we want to replace them. And there is an attempt that's called Magic Links. There is a startup, Magic, for example, that helps with that. And if you've seen on Slack, for example, it says, do you want to give us your password, or do you want to send do you want us to send a unique link into your email? And you click that and it's fine. We know it's you. And they solve some of those problems, because you don't have to remember anything anymore. You don't need to memorize something. You get a unique link into your email and that's it. However, there are problems with leaks and phishing, like someone can convince you to give them this magic link, and there's nothing to protect you against that. And you may be a professional that knows what they're doing, but not everyone does. And phishing is still a very powerful attack against users. And their proper use is still difficult. They're not completely seamless, especially with users that don't typically use email anymore. From younger generations, for example, and this complicates things. They're not completely seamless yet, but these are nothing compared to the worst problem, because I visited this startup's website yesterday, and it turns out that they pivoted to Web3. So what could be worse than that? From a company that seeks user trust. Now they apparently also provide wallets for cryptocurrencies and all of that. So I don't know. It's not really good. So looks like we're left with passwords again. And passwords is basically, it is a word that I use to get access to pass somewhere. And it is a word that I have to remember, and it has all those problems. But what if instead of a word I had a key? So now it's different. What if I had a pass key? And this thing exists apparently, and it is already available out there. The standard behind it is called Web Auth or Web Authentication. So it has been standardized. It's not a proprietary solution or anything like that. And it has been standardized in W3C. So it is a web standard with many contributors, both companies that you can see here and individual contributors participating in its creation. And instead of passwords, this standard basically uses cryptographic keys. So you no longer have to remember a password or something like that. You just need a private key. So let's look a bit into how this works with some images from Cisco here. This is the registration flow. So you say you want to create an account, you send a public key, you generate a new private key, you send the website the public key, and that's it. That's the entire registration flow. In order to log in, you need to prove that for the public key the website has in their database, you have control of the private key. So what happens is the server gives you some random data, and if you can produce a valid signature for this data with the public key, that the server can verify with the public key in their database, that's it, you can log in. And now you may have some flashbacks, some nightmares now, and you may say, okay, like, is this GPG? and I'm happy to say that it's not. We've hopefully learned from the mistakes of the past, and that we are trying to not repeat them again in the future. So what I would see it most like is like SSH keys ++, but not in the context of C++, more in the context of better and improved, and so kind of a different thing. Don't confuse these two. And what's the user experience though? Because SSH keys, they require terminal access and all of that. Do you have to copy files over? Luckily, no, you don't have to do that. Major operating systems, like all of Apple's operating systems, Chrome OS, Android, Windows, and major browsers like Chrome, they have built-in support for passkeys already. And this is available to users running stable versions of iOS, for example, and macOS. And basically everything is handled transparently to the user. Every time you need to log in somewhere, you may use your fingerprint, or you may have your face scanned with Face ID or something like that. The website gets no access to this information. This all happens locally on your computer or phone, and it's basically stored in a secure part of the processor that manages all those keys and synchronizes them across your devices securely. And this works for mobile applications too. But if you're not convinced that this happens fine, you can also get dedicated hardware modules. So these are like USB devices, either small ones that you can always have plugged to your computer, or larger ones for your keychain, for example. And you can buy them, and because you don't want someone to just steal your keys and then log in everywhere, they support, for example, a PIN code. And there are limited attempts before the device effectively destroys all the data in it. And there are also hardware devices with a fingerprint sensor, for example. So you don't even have to set a PIN if you don't want to. Now let's look at the problems that passwords had. They're difficult to remember, for example. With passkeys, there is nothing to remember. You just you do the same thing you do when you log in and unlock your laptop screen. You basically put your finger in a fingerprint reader, and that's it. Everything else is taken care of for you. And what about leaks? This is not a problem because those keys cannot be extracted. They never get out of your secure device, be it a hardware module or your computer. They're never sent to the website or over the network anywhere. So nobody has access to that. They just give you some random data, and then you prove that you can sign this data with your private key. That's all. The key never leaves your computer. And they cannot be fizzed or stolen. Every key is not just, you don't have one key, you have one per website, and this is tied to the domain of the website. So even if you wanted to, you could not produce a valid signature for a different website. There's nothing that an attacker can convince you to copy and give to them. It's not something that a user can be tricked on. And proper use is difficult even for professionals. This is hopefully no longer the case. It's very well integrated into all major operating systems and browsers. There are many solutions available on how to use it, so this should not be a problem. And I think that passkeys basically solve all those problems that passwords have, and will help us get into a passwordless future, where entire classes of attacks are prevented with them. The only thing that I need from you to do is to just support them, basically. Add support for them in your applications, your services, your websites. There are great resources by Apple on passkeys that include everything from design, technical resources, everything you want. There is a nice blog post from a colleague on how to implement them in a very easy way in practice that I strongly recommend reading. And then there are two websites similar to jwt.io, I assume, that have interactive examples and tests and code that you can use. And 1Password maintains a passkey directory. This is a directory of all websites that support logging in with passkeys already. It's not complete, it's community driven, and you can even add your website and application there. This should be fine. And to convince you that this is something that even password managers like, major password managers have announcements out there that they plan to support passkeys and eventually move to either allow you to log into a password manager with passkeys, or even support the management of passkeys if you don't want to use your operating system or a hardware key. So this is all I had for tonight. I don't want to keep you from your food and drinks. Enjoy the discussions, and I'm happy to have any questions either here or on Slack or by email.
Great, thank you, Antonio.
Okay, looks like you're all hungry, unless I can't hear.
No, I have a question.
Oh, of course you do. Go ahead.
I want to go second if there's another question.
Sorry?
I said I want to go second if there's another question.
Oh, okay.
Okay, something that happens to me is that I lose my keys.
Yes.
What happens if you lose your passkeys?
That's the great thing I would say about them, that by like the default, how you should implement passkeys in your application is that you add support for multiple of them. So you can have 5 passkeys in your account. You can have your macOS key and 2 hardware keys if you want. It's like having 5 different passwords for a website, only much better. In fact, like, because there is some migrations, like websites currently use passwords and they may want to add support for passkeys, this can happen over time. So for example, a good advice is to add support for passkeys and then ask the user if they want to disable password access only after they added 2 or 3 keys to their account. And there are some metadata that can tell you whether a key is backed up or not. So the macOS keys or the Windows keys, for example, they can be backed up by the operating system, but hardware keys cannot. So you can decide, for example, you can say, I will let the user disable the password, or I will let the user register without a password if they have either 1 key that is backed up or 2 keys that are not backed up, for example. You can do whatever you want with that.
Question first. I think it's also similar to losing your credit card. Right? It's not like you cannot trust any passkey vendor, but there must be some way to validate the issuer of that passkey in the end. So what you do when you lose your credit card is you invalidate the credit card, right? That's what you do. You call the trustworthy party and you say, hey, credit card company, I lost my credit card, right? And therefore they invalidate it. So there must be a way from the issuer of the passkey, whatever that is, right, to invalidate it.
I don't know, I'm not sure I like that, because like I still need a way to authenticate myself with this trusted issuer. And what is that? Is that another password?
Yeah, exactly.
So I'm not sure I heard the first part, but what I can say is that some of the metadata you receive, like whether this key is backed up or not, it's more difficult to trust this data. And there is a system there that can verify manufacturers basically of keys. So Apple or Ubico that makes the hardware keys or something like that. So you can have a level of trust in addition to just the private key. But other than that, It is just a private key, and it just signs data, specific data in a specific way.
Maybe another closer example are the certificates, the X509 certificate, for example. Usually the trade-off is supporting the revocation lists, right? Because you trust the manufacturer in this case, or the equivalent of the manufacturer, which is the part of the decision certificate.
Yeah.
But to revocate the certificate, you need to support the revocation list.
Yeah. So this, this mechanism does not need revocation for passkeys because they're not certificates. You just have the public key. If it's in your database, it is valid. If it's not in your database, it's not. So if I lose my key, I can log into my Google account and remove it from there. And that's how I revoke it. And because there is no relying party outside of that, it's the service itself that does everything. It already has the authoritative databases of which keys are valid and which are not. For manufacturer keys, which are not needed to implement passkeys, but if you want, for example, to get some attestation from a security key about some of its properties, this uses certificates, but because the firmware of those keys cannot change, you SIP them and that's it, for security reasons. Like some keys may support updates with a mechanism, but most SIP'd today don't. Then for those keys, there is no real concept of revocation because it is every key on the factory gets its certificate, and you may decide to distrust a batch of certificates because it was manufactured improperly.
Thanks.
Thanks a lot.
Mm.
Enjoy, Danny.
No problem. Enjoy.